Before we define the spectral load cases, we need to set up the response spectra. To do this, we go to the Define menu, then Functions, and then Response Spectrum. We'll select ASCE 722 code and click Add New Function. Here we'll name our function. The damping ratio is set at 5%, which is what the code specifies. Now we need to manually input the values for STS and ST1, which we have already calculated. We'll enter 1.03 for STS and 0.57 for ST1. The line period is set at 12 seconds, and our site class is C. Once these are entered, we have defined the function and click OK. Now to define the spectral load cases, we go to Define menu and click on Load Cases. Then we click on Add New Case. To set up the spectral load cases, we do something similar to the static analysis. Just like we had an EX with eccentricity and an EXPN with accidental eccentricity, and did the same for the Y direction, we'll do the same for the response spectrum analysis. So first, let's define SX. In the load case type, we choose response spectrum. Then click Add. It's under the acceleration type. And since it's in the X direction, we select U1. For the function, we pick the func1 we defined earlier. The scale factor is defined in the code under response spectrum analysis in section 12.9.1.2. It states that the response spectra should be divided by R over I. So our scale factor here is I divided by R multiplied by G. If we calculate using this table, with I equal to 1 and R equal to 8, our scale factor, I divided by R multiplied by G in centimeters per second squared, comes out to this value. So that's the scale factor we need to input. We don't need to adjust the settings in the lower parts. The modal load case type stays as modal, and the modal combination method will stick with CQC because it's more accurate than SRSS. The damping ratio is set to 5%, and the eccentricity is left as 0 for this load case. So I'll go ahead and click OK. Next, I used the Add Copy of Case option to create a similar load case for SXPN, but this time with eccentricity. So here, I click on Modify next to eccentricity and set it to 5%. Then hit OK. Finally, I'll repeat the same steps to set up the load cases for the Y direction. In this case, we just need to change U1 to U2, while keeping the rest of the settings the same. Alright, now I need to set up two more load cases similar to SX and SY, but with a key difference. In these new load cases, we won't include the scale factor adjustment. When we are doing the base shear scaling, we need to calculate the adjustment factor based on the ratio between the base shear force from the response spectrum analysis and the equivalent lateral force analysis. So for each step of scaling, we need the base shear value from the response spectrum analysis calculated purely with the I over R times G factor, without any additional adjustment. That's why we need to define two more spectral load cases in ETABS with a consistent scale factor of I, G over R throughout the analysis and design process. We'll call them SX base and SY base. So I'll go ahead and set up these load cases as well.